Come
Come on.
Okay. Okay.
Farting.
Yes.
Yeah.
So what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply.
Simple random, and the mean is distributed normally.
Yeah, I think so.
Yep.
Awesome. Okay. So the test statistic for a hypothesis test comparing two means with independent samples is a t-score.
Are independent if group 1 tells you nothing about subjects in group 2.
Right.
Agree. Okay, dentist office bills.
So for the degrees of freedom, I got 38. Oh wait, and it's a decimal.
37.996.
Yeah, I haven't seen a decimal before. Yeah, so 37.996. Okay, so for the Rexford standard deviation, I got 206.637.
Yeah, I got that too.
Yeah.
And for the test statistic, negative 0.434.
Negative 0.what34?
434.
434. I thought you said 534.
Yeah. Okay, and then the p-value is 0.667.
Well, we need to round to 3 decimal places. Okay. Okay.
Oh wait, hey, I'm wrong. I didn't have the right level of significance.
What?
No, that's good. Sorry. Okay, so we reject the null because our p-value was lower than our level of significance. Oh wait, sorry. Gosh, I can't keep those straight. Okay, so we failed to reject.
Yeah, fail to reject.
0.333, right?
What? For what?
The p-value?
I got 0.667.
Yeah, that's what I got.
Really?
Mm-hmm.
What confidence level are you guys using?
0.9.
0.9?
Yeah, but
And we're doing less than?
it should be not equal to, right?
Should be,
Or maybe it
not
doesn't.
mistaken. Yeah, it says alternative hypothesis should be
Oh, you're right.
mean 1 less than.
Sorry, I got dropped.
No worries.
We were just talking about the type of test. Wait, so
You in the information that
yeah.
less than.
So when it's in less than, that's saying variable 1 is less than variable 2. Not
Right.
But-
down.
Yeah.
Or are
So
we saying,
do we want to double check? Is what we're saying.
yeah, I'm just not sure if it's like, is it saying 1 is less than 2 or 2 is less than 1?
Saying in the
The alternative
it
hypothesis.
says 1 is less than 2. Correction it gives you.
Yeah.
Okay. Okay, we'll do less than. So yeah, in that case, then I got 0.333 for the p-value.
And I don't think it's right. Test statistic is still negative 0.434.
Yeah.
Yeah. Everything else is the same.
And you still reject the null, so it doesn't matter.
No, we should fail to reject the null, right?
No, because it's still bigger.
Less than you reject. Oh, we're looking at
It's
0.1.
not less
Yeah,
than though. Yeah.
yeah. So you fail to reject.
Okay. Okay.
See, what if it was not equal to?
Let's see.
Okay. So if it was not equal to, that would be the p-value that we had before. So we would still
Would be
have,
the second option.
yes.
Insufficient evidence. They're different.
Mm-hmm.
No, freshman dinner.
Isn't the alternative hypothesis that it's not equal to?
On that second one, yeah.
Okay, great. I just want to make sure that my data sheet is correct. You guys have 2 fewer numbers for Colorado than for Utah, right?
Yeah.
Mm-hmm.
Okay, great. I just want to make sure I didn't accidentally delete something.
No, we're good.
For the test statistic, I got 0.845.
Eight, 4, 5, right?
Mhm.
So this one we failed to reject. Sorry, the p value is 0.411.
Awesome, that's what I got.
Then we failed to reject.
Yeah. Did you guys do 12 already?
Oh. Yeah, we lost Haley again.
Hmm.
Yes, we did do 12. We're looking
Okay.
for if there's a difference between freshman in Utah and freshman in Colorado, so it's not.
Okay. That's what I was thinking. I never heard you guys say it, so I didn't know. That's right.
Okay. I don't know where Haley went. I think she got dropped again.
She usually comes back pretty quick, so hopefully give her a second. Waiting. Are you guys down to 16?
Yeah.
Yeah.
Apparently, I don't understand how to do this right because I missed this on the homework. I missed, and I swear I was doing it right. So, do we mind if we just go through the margin of error together?
Yeah.
Crazy.
Okay, so we have
Yeah. Whew.
so this isn't just the upper and lower bound of the confidence interval we already have, right? Or is it?
I think.
Well, it sounds like it's doing it off of the difference between the two.
Yeah, but so would that, I mean, the only time we find the difference is with a paired sample t-test.
Mm-hmm.
But this isn't a paired
We
sample
need to
t-test.
drop it in the t-test chart.
Maybe.
Try that.
Hmm.
Okay, so I guess we can try the paired sample t-test to get the confidence intervals and everything. And then if that doesn't work, then we can just go back to the two sample t-test.
Okay.
So, Jeremiah, what I've been doing to find the margin of error is I just take the confidence intervals and I like find the difference between them. So I'll take like 5.694 and add 1.664 and then just divide it by 2, and that's the margin of error.
Wait, what numbers were you saying? 'Cause I don't
Numbers are
think
you
I-
talking about?
Did we put everything into the paired sample t-test? Or are we
I
doing
did.
the 2-sample t-test?
Oh, I don't know.
I have them both plugged in right now. I have them both plugged in right now.
Okay, so those numbers were from the paired sample t-test under the confidence
Right,
interval.
so you just grab the confidence interval. Okay.
Yeah, so I just find the difference between them and then divide by 2, and that's the margin of error.
How do you know which one you're putting first? Because you said 5.694 first.
Yeah, I just yeah, I just find the difference between them. I mean, you can like subtract them from each other, but
They'll
like
still
you're
come
just
out.
trying to find the distance between those two numbers. So I just find it
So
easier to make both
you got
add them together.
3.694.
Yes.
Okay. Now the paired sample t-test is coming out with a different confidence interval than the 2-sample t-test. We're supposed to use paired sample for you're
Yeah.
calculating the difference, right?
Mm-hmm.
Should
Yeah,
be.
that's up to Haley. Okay, so for the lower boundary, I've got negative 1.694.
I don't think we should be doing it that way because I was looking in the lesson 13 instructions.
Mm-hmm.
To obtain the confidence interval for the difference in two means with independent samples, which is what we're doing,
Right.
be using the 2-sample t-test, column B, and then getting confidence levels F.
Oh, so we use the confidence intervals in the 2-sample t-test?
T-test is what that says.
Okay, so we're using the ones for the 2-sample t-test then.
Yeah, that's in the lesson, so I'm going to assume so.
Okay.
Let me rework that and make sure
Okay.
I get it right.
No problem. So then the margin of error is 3.681.
681. Yeah, that's what I got.
Okay. Okay, I'm gonna go ahead and submit it and see how that went.
You already texted Haley.
Okay, so we missed. What did you guys get for 13?
13.
Yeah. What did
Point
you
eight.
miss to total?
0.845.
Okay. Oh, Hannah just lost it. One sec.
That's what we got wrong.
Yeah, so that one's wrong. So 13 is wrong. And 17 and 18 are wrong.
And 18.
17 and 18.
What did you guys
What
have
we
for
got.
17 and 18?
So negative 2.214.
Okay, yeah.
5.174.
So those are wrong.
Negative 2.214 and 5.147 for 18.
Yeah, and those two are wrong.
But we still got the margin of error, right?
Yep.
How? Thing I can think of is fractions different, and it should be negative 5.147 and positive 2.214.
Has that happened before?
Yeah. Let me. What I can do just to test that out. If you switch the two columns, you get a confidence interval of the opposite, so negative 5.147 and 2.214.
Okay.
Let me see if that makes a difference. Yeah, I'm just gonna have to move those over. Give me. We have to have the right numbers, otherwise we would have never gotten the margin of error correct.
Yeah.
Yeah.
I mean, the only other thing I could maybe think of is if we're off by like the last digit, but yeah, so let us know how that works.
Yeah, but I mean, we don't even have control over that. We're using the system they provide.
Yeah, that's true.
Did we discuss 13?
No, so that's okay. So it's using the
Or
same
submit.
information. When you switch them like you did, does that change the t value?
The t-value, it went from a positive to a negative.
Okay.
Negative 0.845.
Okay, so does someone want to try putting those in?
Yeah, I'm going to try it right now. Did we miss anything else?
Nope, it was just those ones.
All right, let's see how it goes. Cross our fingers.
For real. Hopefully we can
Okay.
get repeated last time.
So otherwise, I have no idea. Come on now, computer. 100%. That's what it was.
Okay, so what did you do for 17? Did you just make that one positive, or did you just completely switch them around?
No, so so both numbers switch, and they switch positive and negative. So if you want to test it and do it yourself, you just have to switch.
The
So you have to
columns?
move column 2 to column 1 to column 2. Opposite, but question 17 is negative 5.147 is positive 2.214.
Okay.
Same for 13 because we switch the values, p becomes negative, so it's negative
Oh,
That's
yeah,
annoying.
0.845.
well, in the instructions for the for like all of those questions, it says let mu1 represent the number of times a month that a student from Colorado cooks dinner, and 2
Oh,
represent
so
the
they
number for Utah.
So they switched, so we just
didn't
let me
take
see.
Yeah, I mean those things, they're really long, so I don't read them all anyway.
Well, we figured it out, so we're good.
In the end.
That's what matters. So let us know what's going on.
Okay, and then Jeremiah, if you want to text all that to Haley, that'd be awesome.
Yep, that's what I'm doing right now.
Awesome.
Awesome.
Because you already told her it was 13, 17, and 18 that we got wrong, right?
Yeah.
Okay. Alrighty. Was there anything else that you guys wanted to go over this morning?
No.
I think that's it. I'm just putting in the last number right now.
Oh, awesome. Yeah, make sure it goes through correctly.
I think it's my last chance, so hopefully.
Yeah.
Okay. Awesome, 100%.
Cool.
Good catch, Jeremiah.
Alrighty, guys. Well, hopefully we'll have Haley back.
Yeah.
See you guys on Tuesday.
Yeah.
Cool. See you next week. Bye.
All right, bye.
Bye.